Python reference. In Python, a reference is a variable that holds the memory address of an object. Here's a breakdown. Reference, a variable that points to an object in memory. Object, the actual data stored in memory, example string, list, dictionary. Memory address, the location in memory where the object is stored. When you assign an object to a variable, you're creating a reference to that object. The variable doesn't store the object itself, but rather a pointer to the object's location in memory. Example. My_list equals 1, 2, 3 hashtag create an object, list, in memory. Print, id, my_list, hashtag print the memory address of the object. My_ref equals my_list hashtag create a reference to the object. Print, id, my_ref, hashtag print the same memory address. In this example, my_list and my_ref are references to the same object in memory. Changing the object through one reference affects the other reference. Understanding references is crucial in Python, as it impacts how you work with variables, objects, and memory management. Python built-in functions. Here's a concise Python reference guide, covering key concepts, libraries, and syntax. 1. Basic syntax. Variables. X equals 10. Y equals hello, world. Data types. Integer equals 10. Floating underscore point equals 10.5. Boolean equals true. String equals text. List underscore example equals 1, 2, 3. Dictionary underscore example equals key, value. Conditionals. If x5. Print, x is greater than 5. If x equals 5. Print, x equals 5. Else. Print, x is less than 5. Loops. For I in range, 5. Print, I. While x15. X plus equals 1. 2 functions. Defining functions. Def my_function, a, b. Return a plus b. Lambda functions. Add equals lambda x, y, x plus y. 3. Object-oriented programming, OOP. Classes and objects. Class dog. Def underscore init__, self, name, breed. Self.name equals name. Self.breed equals breed. Def bark, self. Print, f self.name says woof. My_dog equals dog, buddy, golden retriever. My_dog.bark. 4 common libraries. Math and random. Import math. Print, math.sqrt, 16. Import random. Print, random.randint, 1, 10. File IO. With open, file.txt, w, as file. File.write, hello, file. With open, file.txt, r, as file. Content equals file.read. Date and time. Import datetime. Current underscore time equals datetime.datetime.now. Print, current underscore time. 5 Python libraries. NumPy. Import numpy as np. Arr equals np.array, 1, 2, 3. Pandas. Import pandas as pd. Df equals pd data frame, a, 1, 2, b, 3, 4. Requests, http requests. Import requests. Response equals requests.get, https://example.com. Print, response.txt. 6. Error handling. Try/accept. Try. Result equals 10/0. Accept 0 division error. Print, you can't divide by 0. 7. Virtual environments and package management. Creating virtual environments. Python env. Installing packages. Pip install package _name. 8. Decorators. Function decorators. Def my _decorator, func. Def wrapper. Print, something before the function. Func. Print, something after the function. Return wrapper. At my _decorator. Def say _hello. Print, hello. Say _hello. Python string methods. Strings in Python are immutable sequences of characters, and they come with a rich set of methods that allow you to perform various operations on them. These methods provide a convenient way to manipulate, format, and extract information from strings. Key categories of string methods. Access and slicing. strindex accesses the character at the specified index, 0-based. str_start_stop step extracts a substring from the given indices, optionally specifying a step. strfind sub start end returns the index of the first occurrence of a substring within the string, or -1 if not found. strrefind sub start end returns the index of the last occurrence of a substring within the string, or -1 if not found. str starts with prefix start and checks if the string starts with the specified prefix. str ends with suffix start and checks if the string ends with the specified suffix. strcount sub start and counts the number of occurrences of a substring within the string. strindex sub start and similar to strfind, but raises a value error if the substring is not found. strindex sub start and similar to strrefind, but raises a value error if the substring is not found. Modification. strreplace old, new count replaces occurrences of a substring with a new string. strlower converts all characters to lowercase. strupper converts all characters to uppercase. strcapitalize capitalizes the first character of the string. strtitle capitalizes the first character of each word in the string. strswapcase swaps the case of all characters in the string. strstrip removes leading and trailing wit space from the string. strlstrip removes leading wit space from the string. strrstrip removes trailing wit space from the string. Joining and splitting. strjoin iterable joins elements of an iterable with the string as a separator. strsplit sep equals none, maxsplit equals -1 splits the string into a list of substrings based on the specified separator. strsplitlines keep ends equals false splits the string into a list of lines. Formatting. strformat *args quarks formats the string using placeholders and arguments. fstrings formatted string literals, a convenient way to format strings using expressions within curly braces. Examples. Python. #access and slicing. String equals hello, world. Char equals string 0 #output, h. Substring equals string 712 #output, world. Index equals string.find, world, #output, 7. Hashtag modification. New underscore string equals string dot replace, world, Python, hashtag output, hello, Python. Lower underscore string equals string dot lower, hashtag output, hello, world. Upper underscore string equals string dot upper, hashtag output, hello, world. Hashtag joining and splitting. Joined underscore string equals dash dot join, apple, banana, cherry, hashtag output, apple banana cherry. Split underscore string equals string dot split, hashtag output, hello, world. Hashtag formatting. Formatted underscore string equals hello. You are years old. Format, Alice, 30, hashtag output, hello, Alice. You are 30 years old. F underscore string equals F hello, string. Hashtag output, hello, hello, world. Python list/array methods. Here are some common Python list/array methods. Modifying methods. 1. Append, element adds an element to the end of the list. 2. Insert, index, element inserts an element at a specified index. 3. Extend, iterable adds multiple elements from an iterable to the end of the list. 4. Remove, element removes the first occurrence of an element. 5. Pop, index removes an element at a specified index and returns it. 6. Sort, sorts the list in ascending order. 7. Reverse, reverses the order of the list. Accessing methods. 1. Index, element returns the index of the first occurrence of an element. 2. Count, element returns the number of occurrences of an element. 3. Len, returns the length of the list. Slicing methods. 1. List start stop, returns a slice of the list from start to stop. 2. List start stop step, returns a slice with a specified step. Other methods. 1. Clear, removes all elements from the list. 2. Copy, returns a shallow copy of the list. 3. Join, iterable concatenates elements from an iterable into a string. 4. Max, returns the maximum element in the list. 5. Min, returns the minimum element in the list. 6. Sum, returns the sum of all elements in the list. Note, some methods, like sort and reverse, modify the list in place, while others, like max and min, return a new value without modifying the list. Python dictionary methods. Python dictionary methods. Dictionaries in Python are unordered collections of key-value pairs. Each key must be unique, and the values can be of any data type. Dictionaries provide efficient methods for accessing, modifying, and iterating over their contents. Key categories of dictionary methods. Accessing and modifying. Dict key accesses the value associated with the given key. Dict key equals value sets the value for the given key. Del dict key deletes the key value pair. Dict.get key default equals none returns the value associated with the key, or a default value if the key is not found. Dict.setDefault key default equals none returns the value associated with the key, or sets it to the default value if the key is not found. Iterating. Dict.keys returns a view of the dictionary's keys. Dict.values returns a view of the dictionary's values. Dict.items returns a view of the dictionary's key-value pairs as tuples. For key value in dict.items, iterates over the key-value pairs of the dictionary. Updating. Dict.update, other underscore dict updates the dictionary with the key-value pairs from another dictionary. Dict.clear, removes all key-value pairs from the dictionary. Checking and copying. Dict.copy, returns a shallow copy of the dictionary. Dict.pop, key, default equals none removes the key value pair and returns the value, or a default value if the key is not found. Dict.popetum removes and returns a random key value pair from the dictionary. Dict.fromKeys, iterable, value equals none creates a new dictionary with the specified keys and values. Dict.has_key, key, deprecated, checks if the key is present in the dictionary. Use key in dict instead. Len, dict returns the number of key value pairs in the dictionary. Examples. Python. Hashtag creating a dictionary. My_dict equals name, Alice, age, 30, city, New York. Hashtag accessing and modifying. Name equals my_dict name hashtag output, Alice. My_dict age equals 31. Del my_dict city. Hashtag iterating. For key, value in my_dict.items. Print, key, value, hashtag output, name Alice, age 31. Hashtag updating. Other_dict equals country, USA. My_dict.update, other_dict. Hashtag checking and copying. Copy_dict equals my_dict.copy. Value equals my_dict.pop, name, hashtag output, Alice. Key_value_pair equals my_dict.popetum, hashtag output, H, 31. New_dict equals dict.fromKeys, A, B, C, 0. Python tuple method. Tuples in Python are immutable sequences of elements, similar to lists but with the key difference that they cannot be modified once created. While tuples have fewer methods compared to lists, they still offer some essential functions for working with them. Key tuple methods. Indexing and slicing. Tuple index accesses the element at the specified index, 0-based. Tuple start-stop step extracts a subtuple from the given indices, optionally specifying a step. Length. Len, tuple returns the number of elements in the tuple. Concatenation and repetition. Tuple 1 plus tuple 2 concatenates two tuples. Tuple *n repeats the tuple n times. Membership testing. In checks if an element is present in the tuple. Not in checks if an element is not present in the tuple. Count. Tuple.count element returns the number of occurrences of an element in the tuple. Index. Tuple.index element returns the index of the first occurrence of an element in the tuple. Raises a value error if the element is not found. Examples. Hashtag creating a tuple. My_tuple equals 1, 2, 3, hello, world. Hashtag indexing and slicing. First underscore element equals my_tuple 0 hashtag output, 1. Subtuple equals my_tuple 2:4 hashtag output, 3, hello. Hashtag length. Length equals len, my_tuple, hashtag output, 5. Hashtag concatenation and repetition. New_tuple equals my_tuple plus 4, 5, hashtag output, 1, 2, 3, hello, world, 4, 5. Repeated _tuple equals my_tuple asterisk 2 hashtag output, 1, 2, 3, hello, world, 1, 2, 3, hello, world. Hashtag membership testing. Is _present equals 2 in my_tuple hashtag output, true. Hashtag count and index. Count equals my_tuple.count, hello, hashtag output, 1. Index equals my_tuple.index, world, Hashtag output, 4. Note, while tuples are immutable, you can create new tuples from existing ones using operations like concatenation, repetition, and slicing. Python set methods. Python provides several built-in methods for working with sets. Here's a summary of common set methods. 1. Basic set operations. Add adds an element to the set. My_set equals 1, 2, 3. My_set.add, 4. Hashtag my_set is now 1, 2, 3, 4. Remove removes a specific element from the set. Raises a key error if the element is not found. My_set.remove, 2. Hashtag my_set is now 1, 3, 4. Discard removes a specific element from the set. Does nothing if the element is not found. My_set.discard, 5. Hashtag my_set remains 1, 3, 4. Pop removes and returns an arbitrary element from the set. Raises a key error if the set is empty. Popped_element equals my_set.pop. Hashtag my_set is now 3, 4. Popped_element might be 1. Clear removes all elements from the set. My_set.clear. Hashtag my_set is now an empty set. Copy returns a shallow copy of the set. My_set equals 1, 2, 3. New_set equals my_set.copy. Hashtag new_set is 1, 2, 3. 2 set operations. Union returns a new set with all elements from both sets. Set 1 equals 1, 2, 3. Set 2 equals 3, 4, 5. Union_set equals set1.union, set 2. Hashtag union_set is 1, 2, 3, 4, 5. Update adds elements from another set or iterable to the current set. Set1.update, set 2. Hashtag set1 is now 1, 2, 3, 4, 5. Intersection returns a new set with elements common to both sets. Intersection_set equals set1.intersection, set 2. Hashtag intersection_set is 3. Intersection_update updates the set with the intersection of itself and another. Set1.intersection_update, set 2. Hashtag set1 is now 3. Difference returns a new set with elements in the set that are not in the other set. Difference_set equals set1.difference, set 2. Hashtag difference_set is 1, 2 if set 1 was 1, 2, 3. Difference_update updates the set, removing elements found in another set. Set1.difference_update, set 2. Hashtag set1 is now 1, 2 if set 1 was 1, 2, 3. Symmetric_difference returns a new set with elements in either set but not in both. Sim_diff_set equals set1.symmetric_difference, set 2. Hashtag sim_diff_set is 1, 2, 4, 5. Symmetric_difference_update updates the set with the symmetric difference. Set1.symmetric_difference_update, set 2. Hashtag set1 is now 1, 2, 4, 5. 3 subset and superset operations. Is_subset checks if the set is a subset of another set. Is_subset equals set1.isSubset, set 2. Hashtag returns true if set 1 is a subset of set 2. Is_superset checks if the set is a superset of another set. Is_superset equals set1.isSuperset, set 2. Hashtag returns true if set 1 is a superset of set 2. Is disjoint, checks if two sets have no elements in common. R underscore disjoint equals set 1 dot is disjoint, set 2. Hashtag returns true if set 1 and set 2 have no common elements. For conversion, frozen set returns an immutable version of a set. Frozen equals frozen set, 1, 2, 3. Hashtag frozen is frozen set, 1, 2, 3. These methods make Python sets versatile for various operations like union, intersection, difference, and more. Let me know if you need examples or further explanation on any specific method. Response 2. Here is a summary of Python's built-in set methods. Common set methods. Add item adds a single element to the set. S equals 1, 2, 3. S.add 4. Print S hashtag output 1, 2, 3, 4. Remove item removes the specified element from the set. Raises a key error if the element is not found. S.remove 3. Print S hashtag output 1, 2, 4. Discard item removes the specified element from the set, but does not raise an error if the element is not found. S.discard 5. Print S hashtag output 1, 2, 4. Clear removes all elements from the set. S.clear. Print S hashtag output set. Copy returns a shallow copy of the set. S2 equals S.copy. Union asterisk other underscore sets returns a set that is the union of multiple sets, i.e., all unique elements from all sets. Set 1 equals 1, 2, 3. Set 2 equals 3, 4, 5. Set 3 equals set 1 dot union, set 2, hashtag output, 1, 2, 3, 4, 5. Intersection, asterisk other underscore sets. Returns a set with elements common to all sets, i.e., the intersection. Set 3 equals set 1 dot intersection, set 2, hashtag output, 3. Difference, asterisk other underscore sets. Returns a set with elements that are only in the original set and not in any of the other sets. Set 3 equals set 1 dot difference, set 2, hashtag output, 1, 2. Symmetric underscore difference, other underscore set. Returns a set with elements in either the set or the other set, but not in both, i.e., the symmetric difference. Set 3 equals set 1 dot symmetric underscore difference, set 2, hashtag output, 1, 2, 4, 5. Update, asterisk other underscore sets. Updates the set by adding elements from other sets, i.e., the union is applied in place. Set 1 dot update, set 2. Print, set 1, hashtag output, 1, 2, 3, 4, 5. Intersection underscore update, asterisk other underscore sets. Updates the set with elements common to all sets, i.e., intersection is applied in place. Set 1 dot intersection underscore update, set 2. Print, set 1, hashtag output, 3. Difference underscore update, asterisk other underscore sets. Updates the set by removing elements found in other sets, i.e., difference is applied in place. Set 1 dot difference underscore update, set 2. Print, set 1, hashtag output, 1, 2. Symmetric underscore difference underscore update, other underscore set. Updates the set to be the symmetric difference of itself in another set, i.e., symmetric difference is applied in place. Set1 dot symmetric underscore difference underscore update, set2. Print, set1, hashtag output, 1, 2, 4, 5. Dot is disjoint, other underscore set. Returns true if the set has no elements in common with another set. Result equals set1 dot is disjoint, set2, hashtag output, false. Dot is subset, other underscore set. Returns true if the set is a subset of another set, i.e., all elements of the set are in the other set. Result equals set1 dot is subset, set2, hashtag output, true. Dot is superset, other underscore set. Returns true if the set is a superset of another set, i.e., all elements of the other set are in the set. Result equals set1 dot is superset, set2, hashtag output, false. Example. Here's an example demonstrating the use of some set methods. Set1 equals 1, 2, 3. Set2 equals 3, 4, 5. Hashtag union. Print, set1 dot union, set2, hashtag output, 1, 2, 3, 4, 5. Hashtag intersection. Print, set1 dot intersection, set2, hashtag output, 3. Hashtag difference. Print, set1 dot difference, set2, hashtag output, 1, 2. Hashtag symmetric difference. Print, set1 dot symmetric underscore difference, set2, hashtag output, 1, 2, 4, 5. Python file methods. Python provides a set of built-in methods for working with files, allowing you to read, write, and manipulate file contents efficiently. These methods are part of the I/O module, which provides a unified interface for various file-like objects. Key file methods. Opening and closing files. Open, file name, mode equals R, encoding equals none opens a file and returns a file object. Mode, specifies the mode in which the file is opened, example R for reading, W for writing, A for appending. Encoding, specifies the character encoding used for the file. File.close, closes the file, releasing any associated resources. Reading from files. File.read, size equals none reads a specified number of bytes from the file and returns them as a string. File.readLine, reads a single line from the file and returns it as a string. File.readLines, reads all lines from the file and returns them as a list of strings. File.seek, offset, whence equals 0 sets the file's current position to the specified offset. Whence, specifies the reference point for the offset, 0 for the beginning, 1 for the current position, 2 for the end. File.tell, returns the file's current position. Writing to files. File.write, string writes a string to the file. File.writelines, lines writes a list of strings to the file, one line per string. File.truncate, size equals none truncates the file to the specified size or to the current position. Examples. Python. Hashtag reading from a file. With open, example.txt, R, as F. Content equals f.read. Print, content. Hashtag writing to a file. With open, output.txt, W, as F. F.write, hello, world. Hashtag appending to a file. With open, log.txt, A, as F. F.write, this is a log message \n. Hashtag reading line by line. With open, data.txt, R, as F. For line in F. Print, line.strip. Hashtag using context managers for automatic closing. With open, file.txt, R, as F. Hashtag operations on the file. Additional considerations. Context managers, using with statements ensures that files are automatically closed even if exceptions occur. File modes. Other modes include RB for reading binary files, WB for writing binary files, and DB for appending to binary files. Encodings. Specify the appropriate encoding, example UTF-8, to handle different character sets correctly. Error handling. Use try-except blocks to handle potential exceptions like IO error or file not found error. Python keywords. Keywords in Python are reserved words that have specific meanings and cannot be used as variable names, function names, or class names. They are essential for the structure and functionality of Python code. List of Python keywords. Endel for not try. As elif from or while. Assert else global pass with. Break except if raise yield. Class exec import return. Continue finally in try. Keyword functions. Control flow. And, or, not, logical operators for conditional statements. If, else, elif, conditional statements for branching execution. For, while, looping constructs for repetitive execution. Break, continue, statements to control the flow within loops. Exception handling. Try, except, else, finally, used to handle exceptions and errors gracefully. Class definition. Class, defines a new class. Function definition. Def, defines a new function. Import statements. Import, from, as, used to import modules and packages. Other keywords. Assert, used for debugging and testing. Del, deletes objects from memory. Exec, executes a string as Python code. Global, declares variables as global. Pass, a placeholder statement that does nothing. Raise, raises an exception. Yield, used in generator functions. Usage examples. Hashtag conditional statement. If x0. Print, x is positive. Else. Print, x is negative or 0. Hashtag looping. For I in range, 5. Print, I. Hashtag function definition. Def greet, name. Print, hello, plus name plus. Hashtag exception handling. Try. Result equals 10/0. Except 0 division error. Print, cannot divide by 0. Important notes. Keywords are case sensitive in Python. Avoid using keywords as variable or function names to prevent conflicts. Understanding keywords is essential for writing correct and readable Python code. Python built-in exceptions. Python provides a variety of built-in exceptions that handle different error conditions during the execution of a program. Here's a list of some commonly used built-in exceptions. Common built-in exceptions. Exception. Base class for all exceptions in Python. Arithmetic error. Base class for all errors that occur during arithmetic operations. Assertion error. Raised when an assert statement fails. Assert 2 plus 2 equals 5 hashtag raises assertion error. Attribute error. Raised when an invalid attribute reference or assignment is attempted. My_list equals 1, 2, 3. My_list.append, hashtag raises attribute error. EOF error. Raised when the input, function hits an end of file condition, Ctrl+D/Unix or Ctrl+Z/Windows. Input, hashtag raises EOF error if EOF is encountered. Floating point error. Raised when a floating point operation fails. Generator exit. Raised when a generator or coroutine is closed using the .close method. Import error. Raised when an import statement has trouble importing a module. Python. Copy code. Import non-existent module hashtag raises import error. Index error. Raised when a sequence, example list, tuple, is indexed out of range. My_list equals 1, 2, 3. Print, my_list 5, hashtag raises index error. Key error. Raised when a dictionary key is not found. My_dict equals a, 1. Print, my_dict b, hashtag raises key error. Keyboard interrupt. Raised when the user interrupts program execution, usually by pressing Ctrl+C. Memory error. Raised when an operation runs out of memory. Name error. Raised when a local or global name is not found. Python. Copy code. Print, unknown_variable, hashtag raises name error. Not implemented error. Raised when an abstract method that needs to be overridden in a subclass is not implemented. Python. Copy code. Class base. Def my_method, self. Raise not implemented error, subclasses should implement this. OS error. Raised when a system function returns a system-related error, like I/O errors. Python. Copy code. Open, non_existent_file.txt, hashtag raises OS error. Overflow error. Raised when the result of an arithmetic operation is too large to be expressed. Recursion error. Raised when the maximum recursion depth is exceeded. Reference error. Raised when a weak reference proxy is used to access an object that has already been garbage collected. Runtime error. Raised when an error occurs that does not fall under any other category. Python. Copy code. Raise runtime error, unexpected error. Stop iteration. Raised by next, to indicate that there are no further items in the iterator. Syntax error. Raised when the parser encounters a syntax error. Eval, x == 2, hashtag raises syntax error. Indentation error. Raised when there is incorrect indentation. Python. Copy code. Def func. Print, hello, hashtag raises indentation error. Tab error. Raised when inconsistent use of tabs and spaces for indentation is found. System error. Raised when the interpreter finds an internal error. System exit. Raised by the sys.exit function. Type error. Raised when an operation or function is applied to an object of inappropriate type. Python. Copy code. Len, 5, hashtag raises type error. Unbound local error. Raised when a local variable is referenced before assignment. Unicode error. Base class for errors related to Unicode encoding/decoding. Value error. Raised when a function receives an argument of the right type but an inappropriate value. Int, hello, hashtag raises value error. Zero division error. Raised when division or modulo by 0 is attempted. 1/0 hashtag raises zero division error. Example of handling exceptions. Here's how you can handle some of these exceptions using try-except blocks. Try x equals int, input, enter a number. Y equals 1/x. Except value error. Print, that's not a valid number. Except 0 division error. Print, cannot divide by 0. Except exception as E. Print, if an unexpected error occurred, E. This will catch and handle common exceptions, and if an unexpected error occurs, it will be caught by the general exception class. Let me know if you want more specific details on handling these exceptions. Python Glossary. A. Abstract Base Class, ABC, a class that defines a common interface for derived classes but cannot be instantiated directly. Argument, a value passed to a function or method. Attribute, a property or characteristic associated with an object. B. Boolean, a data type with two possible values, true or false. Built-in function, a function that is part of the Python standard library and can be used without importing any modules. C. Class, a blueprint for creating objects. Comment, a statement in the code that is ignored by the interpreter and is used for documentation. Compound data type, a data type that can hold multiple values, such as lists, tuples, and dictionaries. Conditional statement, a statement that executes a block of code only if a certain condition is met. D. Data type, a classification of values that determines the kind of operations that can be performed on them. Decorator, a function that modifies the behavior of another function or class. E. Exception, an error that occurs during program execution. Expression, a combination of values, operators, and function calls that produces a result. F. Function, a block of code that performs a specific task and can be reused. I. Immutable, a data type whose values cannot be changed after creation. Instance, an object created from a class. Iterable, an object that can be iterated over, such as a list or tuple. L. List, an ordered collection of elements that can be modified. M. Module, a file containing Python definitions and statements. Method, a function defined within a class. O. Object, an instance of a class, representing a combination of data and behavior. S. Sequence, an ordered collection of elements, such as strings, lists, and tuples. String, a sequence of characters. Syntax, the rules that govern the structure of a programming language. T. Tuple, an ordered collection of elements that cannot be modified. V. Variable, a named storage location for a value.